Today we'll be discussing Lesson 2 in Chapter 6, Systems of Linear Equalities. In today's lesson, we're going to learn a second method for solving systems of equations. If you'll remember, yesterday we learned that you can solve a system of equations by graphing. And the point at which the two graphs intersect is your solution, which solves your system of equations. In today's method, we're going to learn how to use substitution to solve a system of equations. We have an example here with two equations. They're both solved for y. We have y equals x minus 2 and y equals 3x. As it says on the board, our goal with this method is to reduce the two equations to one and to have only one variable which you can then solve. Your first step, therefore, is to make sure that at least one of your equations is solved for either x or y. If you'll notice, in this system of equations, both of our equations are solved for y. So we have, for the top equation, another name for y is x minus 2. Y and x minus 2 are equal. And in the second equation, we see that y is equal to 3x. The second step in this method is to substitute. When we substitute, we're going to put one value in for another. So we're going to substitute x minus 2 into the second equation, because x minus 2 is another name for y. So here we go, we're going to take x minus 2 and we're going to put it in for y. So this becomes x minus 2 equals 3x. X minus 2 took the place of y. Now that we have one equation with one variable, you can solve using the method you already know. So step 3 is to simplify and solve for x. Our first step is to subtract x from each side. That gives us negative 2 equals 3x minus 1x, which is 2x. Our second step for simplifying is to divide both sides by 2. Our 2's cancel, giving us our value for x, which is negative 1. So now we know x equals negative 1. Step 4, now we know our value for x. So now we know x equals negative 1. We're going to substitute negative 1 for x in one of the equations. So we have x equals negative 1. Here's our two original equations. Let's pick the first one. Y equals x minus 2. But now we know we can put our negative 1 in for x. And that gives us y equals negative 1 minus 2, which equals negative 3. Now we know x equals negative 1. And y equals negative 3. So our fifth step is to write our x and y as an ordered pair. this ordered pair, -1, -3, is the solution to our system of equations. To check our solution, we can put our ordered pair into the second equation. So we have the equation y equals 3x. We're going to substitute x equals -1 and y equals -3 into this equation, so it becomes -3 equals 3 times -1, and 3 does equal -3, so it does check. This is the first example. And now here's our second example. In this example, as you can see, we do not have either equation solved for x or y. Our goal is to be able to solve these two equations, making them one equation with one variable. You can either solve for y or x. However, as you can see from the top example, your easiest job will be to solve this equation for y. That will only take one step for you to do. So I'm going to solve the first equation for y. Y plus 6x equals 11. To solve for y, all I do is subtract 6x from each side of my equation. This gives me the equation y equals -6x plus 11. Notice the x term is a -6x and the 11 remains positive. Now I have a value for y. I have another name for y, and that is -6x plus 11. So I'm going to use this name for y and put it in the second equation. So step 2 is to substitute. That's why it's called substitution. We're going to substitute our value for y in the other equation. So here's my y. I'm going to put it in for this y up here. 3x plus 2 times, I'm going to use y equals -6x plus 11. So instead of putting the y here, I'm putting in -6x plus 11 equals -5. Now this looks like a complicated equation, but all I do now is use my rules for simplifying. So step 3 is simplify. I know that my first step will be to distribute, so I'm going to write 3x plus 2 times -6x is -12x. And 2 times 11 is 22 equals -5. Now I have some like terms, and I'll combine my like terms. 3x plus -12x is -9x plus 22 equals -5. I'm solving for x, so I'm going to undo the addition by subtracting 22 from each side. That gives me -9x equals -27. And finally, I will undo my multiplication by dividing both sides by -9, giving me x equals 3. Now I know the x value in my ordered pair. I'm going to substitute this value for x into one of the first equations. So I'm going to pick the first equation, and I'm going to substitute x equal 3 into the first equation. So I have y plus 6x equals 11. I know my value for x is 3. So I write that as 6 plus y plus 6 times 3 equals 11. y equals 18. Let me try that again. Y plus 18 equals 11. And when I subtract 18 from each side, I get y equals -7. Now, if I've done this correctly, I know that my solution is the ordered pair 3, -7. How do I check this solution? How do I make sure that I did not make any mistakes? I use my value for x and y, and I put it in the second equation. So here's my check. I'm going to put it up here. To check, I'm going to take 3x plus 2y equals -5 and use the ordered pair 3, -7. So that becomes 3 times 3 plus 2 times -7 equals -5, and then I simplify. 9 plus -14, which does equal -5. My solution checks I've done the math correctly. Now it's your turn.